wondered why your body jerks forwards when a car brakes suddenly, even when you're wearing a seatbelt? This is not uncomfortable, it's dangerous. Every year in Malaysia, 1,000 of passengers suffer neck and chest injury from sudden braking inside vehicle, especially children and the elderly. But most drivers don't realize that everyday situation is actually controlled by physics. In this video, we will investigate the mechanics sudden braking in cars using two key primary concepts from MAT272, momentum and kinetic energy. This objective of the study is to calculate and compare the momentum and kinetic energy of a car during normal braking versus sudden braking. Using real measured data, reflect on how sudden braking affects passengers safely and the environment in the relation to SDG 3 and SDG 12, and a recommended driving solution that balances technical safety with the values of fairness and responsibility for all road users. Today, we analyze a real-life scenario of MAT272, a car with an empty mass of 1,200 kg travel at a constant velocity of 25 meters per second on a straight highway. We compare two conditions here. Condition A, with a legal 300 kg payload giving a total mass of MA equal to 1,500 kg, and condition B is overloaded with 600 kg payload giving a total mass of MV equal to 1,800 kg. In both cases, the driver applies maximum braking and the braking system provides a constant retarding force of 6,000 Newton. By the end of this video, we'll see why load limits are not just rules, they are physics.
For mechanic analysis, first question, which vehicle has greater inertia? Explain your answer. So condition B has greater inertia because it has larger mass, which is 1,800 kg, compared to condition A, 1,500 kg. According to the concept of inertia, an object with greater mass resists changes in its state of motion more strongly. Second question, which condition has greater momentum and why? So for this question, we will need to calculate the momentum first. So for condition A, using the P equals to mv formula, we substitute the information, which is mass is equal to 1,500 with velocity of 25. Then we will get 3.75 times 10 to the power of 4 kilogram meter per second for condition A. So for condition B, using the same formula with mass equals to 1,800 and the same velocity 25, then we will get 4.50 times 10 to the power of kilogram meter per second. So from this calculation, we can conclude that condition B has greater momentum because it has larger mass while both vehicles travel at the same speed. Third question, which vehicle possesses more kinetic energy? Explain. So for this question, we will calculate the kinetic energy for both conditions using the formula kinetic energy equals to 1 over 2 mv squared. So for condition A, substitute the info, which is mass equals to 1,500 and velocity is 25. And we will get the kinetic energy equals to 4.69 times 10 to the power of 5 joules. So for condition B, using the same formula with mass equal to 1,800 with velocity of 25, then we will get answer of 5.63 times 10 to the power of 5 joules. So from the answer, we can conclude that condition B possesses more kinetic energy because kinetic energy is directly proportional to mass when the velocity is constant. Since condition B has greater mass, it stores more kinetic energy. Why is it important to avoid overloading a vehicle? Overloading increases the vehicle's inertia, momentum, and kinetic energy. Consequently, the vehicle becomes more difficult to stop, increase the braking distance, and raise the risk of accidents. Therefore, overloaded vehicles generally require longer stopping distance and pose greater safety risks.
So, I will talk about ethics and value in this video. Not wearing a seatbelt increased the risk of death from a road accident by 45% and the risk of serious injury by 40% to 50%. Studies also reveal that victims who are not wearing a seatbelt are 30 times more likely to be thrown from the vehicle than those who are wearing one. Statistics related to seatbelt safety has three effects. First of all, cost of death. Cost of death, according to a previous study by Road Transport Department (JPJ), approximately 30% of all deaths in road accidents are caused by vehicle users not wearing seatbelt. Secondly, complaints rate. The rate of near seatbelt use in Malaysia has been recorded at an alarming level. Lastly, effects of throwing out. In cases of victims being thrown out due to not being fastened, 3 out of 4 individuals, 75%, will die from serious injuries. In conclusion, understanding physics concepts like momentum and kinetic energy is vital for road safety. Momentum makes heavier and faster cars much harder to stop, while kinetic energy multiples dangerously as speed increases and also creating massive destructive force. Falling to respect this law of physics explains why 30% of road fatalities in Malaysia involve unbuckled passengers. Therefore, wearing a seatbelt and driving responsibility are not just rules, but they are critical actions to construct physics, save life, and create safer road for everyone. So that's all for us.